record on this company. You can start.
Okay, great. Well, thanks, Lev, very much for inviting me to do this. I'm going to describe the project we've been working on, which is looking at the differences in the languages from countries that are peaceful or not peaceful, from both news media and social media. And if you want to learn more about this, we have a preprint which has been posted on archive. So my background a little bit, I have a bachelor's degree in physics from the City College of New York, and then a PhD in astronomy from Harvard. And I was an assistant professor at the medical school at Columbia University, where Lev worked for me actually for a while. So that was a nice interaction to have had with him.
Yeah, I really enjoyed this time.
Good. After that, I was a professor at Florida Atlantic University, and most recently at the Queens College of the City University of New York. And currently, I'm an adjunct senior research scholar in an interdisciplinary center at Columbia University. And over the years, my previous work has involved mostly looking at data analysis or mathematical modeling in physical systems, such as the motions of ion channel proteins and cell membranes, the motions of stars and gas and galaxies, in biological systems such as gene regulatory networks and the timing of heart attacks, and most lately in social systems, studying the emotional interactions between therapists and their clients in psychotherapy, and also actually looking at commodity prices in ancient Babylon. So most of my current work involves what I'll talk about today, which is the Sustainable Peace Project, but I'm also actively working on studies of the flow of information in networks. And there are a lot of cases now where neural networks produce a really bad answer. A lot of cases where they work really well, but every once in a while do something that's now called either an adversarial example or an hallucination. And I'm currently also studying, trying to understand why that happens. So the goals of the Sustaining Peace Project at Columbia University are to identify the social processes that support and sustain peace, to use machine learning to find the words that reflect or drive peace, and to create new measures of peace from machine learning models based on both news and social media. And what we're hoping to do as a long-term goal is to establish a real-time dashboard which would provide assessment tools for policymakers or academics or journalists to rate the level of peace currently in different countries. So the idea of positive peace is that until recently, most research in peace focused basically on analyzing peace in a negative way. That is the absence of conflict, so conflict resolution studies. But there's been a growing effort lately to understand positive peace, that is, the social systems that generate and sustain peaceful societies. An example of that is actually something that happened here some time ago in New York State, which was the Iroquois Great League of Peace, which was a confederation of 6 of the Native American tribes here in the state of New York. And they maintained peace amongst themselves for nearly 300 years. And they did it in a very active way. They created a myth that they had buried all their implements of war under the Tree of Peace, and all those warfare implements had been washed away by an underground river. But they also reinforced this at an annual peace ceremony where they went over what they were trying to do, and very concrete conflict management teams at the village, tribal, and confederacy levels. It's also interesting, this was a society that also gave important powers to women who could remove chiefs if they felt they weren't doing a good job. And actually, throughout the world currently, societies that actually give a lot of authority to women tend to do a little bit better. So the traditional science approach is a top-down approach. You start with a hypothesis that leads you to equations, which you solve either analytically or here numerically. So then you get a solution here, which would be position as a function of time. But the data science approach is a bottom-up approach. You start with the data. So for example, you have a supervised machine learning model, and you have examples of input and output. And you put those into a system that has adjustable parameters. And then you find the adjustable parameters that best fit and reproduce this training set. So that when you give it a new input it's never seen before, you're hoping you'll get an output that makes sense. So you hope that the model has generalized from all of the inputs it's seen to be able to figure out something it's never seen before. So we don't solve the problem. We create a model that gives good answers trained from previous examples. And then that model solves the problem. So if we were doing this study in a traditional sense, what we would do is conjecture what words are different in conflicts and peace, and then search for the frequency of those words in the data from different countries. But that's not what we're doing. What we're doing is a bottom-up data science approach. We're using natural language processing and machine learning to find the words that the machine learning model best predicts if a country is lower or higher peace. So we're going to train the model, and then the model will tell us what words are more important rather than us hypothesizing what words are more important. This particular project has been going on for the last few years, and we've had so far 6 different teams working on this. So I'm just going to describe some of the highlights of this. Currently, we're working with a team led by another Lev Guzman in Mexico City, and a group here with 2 students here at Columbia University. So the data sources we're using are first this news on the web data source. We're using from that data source data from 18 countries, a little over 700,000 media articles over a 10-year period. And this is from a wide variety of sources. For example, the Austin American-Statesman, which actually I think the reporters in this newspaper are actually currently on strike, actually. But other things besides newspapers, such as the websites of television stations, such as Fox 43 in Pennsylvania and KCCI in Iowa. We've also had some data from LexisNexis from 20 countries with about 2 million media articles, also of a 10-year period. And again, this includes a wide variety of sources, for example, ABC News, Auto Week, and the Business of Fashion. One of the groups of students from the Columbia University Data Science Master's Program scraped the web to get data from 16 countries, about 600,000 articles. And this included sources like News in English from Norway, the Times of India, and the Nigerian Voice. And from those same 16 countries, they also downloaded 800,000 tweets. So what are the lessons that we learned from dealing with this kind of data? Well, first of all, if you look at the text of this, there are a lot of funny things that you really don't want to have there. And so you have to really pre-process the data to get rid of those things. It's also common to remove the named entities, which in the old days used to be called proper nouns, because we don't want the system to train on like a place name and then identify a country as being peaceful just through its place name. We'll also remove what are called stop words, which are basically the common words in the text, because if we use all those words all the time, we want to focus on the words that are different in the different countries that are peaceful or not peaceful. We also want to lamentize the words. That is, we want to consider words like work and works and worked, all sort of the same word in doing the analysis. Well, the only problem with all this is what the standard would be in data science, is James Pennybaker at the University of Texas in Austin has been able to show quite convincingly, and I have a link to his TED YouTube video here, is that the words that people very often take out in pre-processing are actually very important. So these pronouns like I, you, and they, and a whole bunch of other words called function words actually reveal a very lot about people. So Pennybaker has shown that if you use these first-person words a lot, that actually that indicates social status to the person you're talking to. And he gives us an example from analyzing his own emails, that when he talks to his dean, he always says, well, I need a budget to do this, or I'm working on this project, so you need to help me and give me credit for it in this way or whatever. But the dean never writes using first person. The dean writes that the budget is very short, or the facilities are not available to do something. So this is what's usually done, but you really need to be a little bit more careful about this. It strikes me as very odd that people in data science have made certain assumptions about what words are important. And the whole point of data science is not to make those assumptions, but to learn through machine learning or AI from the data what's important. So this is just a little bit of a warning. So the two methods we've used the most are logistic regression, first of all. And here, if we divided the training set into high peace and low peace countries, so these might represent the points as a function of the percentage of the word they use president. So if you were going to fit this by a standard linear method, this line doesn't look really like a nice fit to this data at all. So just about 50 years ago, people figured out what you could do is do a nonlinear transformation of that fit, which is called the logistic equation. So now this line, which represents a better representation of the data, now represents the probability that a value on the x-axis is in class 1. The other method we used was random forest. So you can create a tree, for example, that says if the word president is used frequently, you go down this branch of the tree, and not frequently down the other branch. And each of these nodes can be the frequencies of different words. Well, the problem is if you use all the data to create this graph, then the data becomes too tightly fit to that particular data. And then when you use new data, you don't get very good results. So what's common to do is to take only buckets of data, not the whole data set, and create different trees, literally a random forest from choosing data, and then either pick what is the best tree or what's shown in this illustration, some sort of way of combining the trees. So those are two methods we use the most, but we also use some other methods as well. XGBoost, which is a fancier version of random forest, support vector machines, neural networks. For clustering, we use k-means. In terms of basic natural language processing, we used NLTK and spaCy and Word2Vec. And for more sophisticated natural language processing, we used Google's BERT and Hugging Face's XLNet. So the data here from each country, we computed the normalized word frequency in that country. And we're looking at the 300 most common words in each country. So if we combine that across countries, that leads to 767 words from 18 countries. So we're looking at a data frame of 18 rows versus 767 columns. Then we looked at two different models, a model where we broke the data into 3 classes, low, intermediate, and high peace, and a 2-class model where we only looked at low and high peace countries. I'll explain in a little while why we have those two different classes. Then we did supervised training. So for the 3-class model, we did an 80-20 train text test, should be test and not text split. But since we don't have a lot of different countries, we also used a different cross-validation technique. So if we have all 18 countries, we can use 17 of those countries to predict whether that one excluded country from the training set is peaceful or not peaceful or intermediate peace. And we can repeat this 18 times now. So now this gives us 18 separate points on the confusion matrix. And if we don't have that many countries, if we have more limited data, this provides a much better sample than using the 80-20 training set. Now, the advantage of this is we're using all of the data and doing the training except for that one country. And then it's making a prediction on a country on data it's never seen before. So there's no chance that we've included something in the training that's going to help it. The disadvantage of this is we've got to train this thing 18 times. So there's more computation we need to do here. And we're going to get 18 different models. And then we're going to have to make the choice of which of those are best or how we add them together. The 2-class model has even fewer countries. It's got 10 countries in it. And so now we're going to use 9 countries to predict one and repeat this 10 times, each time excluding a different country. So this is training data. So here are 5 different peace indices that rate the level of peace in different countries. These were the countries we're looking at. And if you take a quick look across here, you know, all these numbers are different. So how are we going to train this thing? And they're all different because each of these indices uses a different scale, and each is looking at slightly different things. So if we're trying to combine things that are different, how do we do that? And again, this is something that occurs in a lot of other machine learning problems. If we have data from different sources, they disagree, how do we handle them? Well, if we're really lucky, it's just a question of normalizing the data in some consistent way across the different sources. We're not in the easy situation. Each index is using a different scale, so we're going to normalize them differently and convert them all to one scale. And we're also going to use another algorithm to help define countries that are peaceful or not peaceful or intermediate in peace. So this shows how we did that. So this is that original data I showed you before. The first thing we're going to do, these scales actually, these first two run from 5 to 1. These other scales run between 0 and 10 and 0 and 120 and 0 and 1. And so what we did is scaled all the scales to be 0 for the lowest value of peace on that scale and 100 for the highest value of peace. And now we have all the numbers. You can see the numbers are beginning to look a little more similar. Now what we want to do is we broke each scale into thirds. So the highest values in each scale in green represent the most peaceful countries. The lowest values represent the least peaceful countries here in red, and the countries that are intermediate in peace are in yellow. So this shows the set of the low, intermediate, and high peace countries. And you can see that they have different amounts of data in terms of the number of words or in terms of the number of articles. And we're now going to train this model on these 3 classes using both an 80-20 split and this cross-validation method. So I was trying to point out that there are different amounts of data from each feature. So how are we going to deal with this? Well, first of all, we've at least normalized the results from each country. So we're looking at the word frequencies over all of the data we have from that country. So we're not going to bias it by putting too many articles from one country. But how do we deal with the fact that there's still different sizes in the articles and different amounts of data from peaceful and not peaceful countries. So there's some standard ways to do that. We could bootstrap this. We could keep picking additional data to fill in the blanks in the data frame if we want to do that. And that might be one way to do it. In the LexisNexis data, some data we have from some countries is 1,000 times the amount of data from other countries. I wouldn't feel happy bootstrapping 99.9% of the data if we're doing something. So sometimes we can do that. Sometimes we can get into trouble doing that. I've also seen someone recently, and I thought this was clever, of taking, if the data is of different features have different amounts of data, we can compare the smaller data sets to the big one and to larger features and look at what the differential is between them. So there are a number of other that can apply to deal with an unbalancing the data, but this is also not so simple and a little bit tricky to do. So these are the results from this 3-class set, and they're not very good. So for the random forest, we get about a 60% accuracy and sort of similar numbers in these other measures. And for the logistic regression, we get between 40 and 60% accuracy. So this is not very good. We're kind of disappointed to see this. So we thought a little bit about this. And if these peace indices disagree with each other, maybe because they're measuring things differently, maybe they're measuring different things. If the humans can't figure out which countries are peaceful or not peaceful, how is our machine learning going to figure it out? But the humans are pretty sure which countries are lower peace and higher peace. So if we look here at the values for Australia, humans pretty sure that Australia is a peaceful country. And if we look down here in the red at the values for Kenya, where humans are pretty sure that those countries are not peaceful. So now what we did is we only use this 2-class training set where we have countries that are not peaceful and countries that are peaceful. And now we're going to train on this data set. We did an 80-20 split on this also, but there's so few countries, 10 countries, that this isn't really so helpful. But we actually can get pretty good data doing the 10 countries, again, each time using 9 to protect the remaining country that it's never seen before. So at least we get 10 points on the confusion matrix. So it gives us some data. And these are the results from that. So for both the random forest, which turns out to be 96% accurate, and for the logistic regression, which perfectly picks at 100% what the value of that excluded country is in terms of peace. So now we have a system that is picking up the things that it wasn't picking up before. So if there are ambiguities in some of the data, maybe sometimes it makes sense to train on the most extreme pieces of data we have, because then the machine learning system can kind of figure out what the differences are. So this is a result of that. And I really do hate people who show slides like this that you can't read. So I apologize for this, but I guess not completely since I'm showing it. But what I want you to look at this slide is not the words. The words going from the top to the bottom through both columns for the peaceful countries on the left and lower peace countries on the right are in order of the frequencies of those words. And those are the words, all of the words. And but the yellow boxes are the words that have been identified by the importance method in the random forest as being the words that the machine learning system is making its decision on. And you can see that those yellow words are not all of the words. So what this means is that some of the words that even appear in highest frequency are not necessarily the words that the machine learning system is using in order to identify whether the country is in lower peace or higher peace. And here's what the words look like. So what I'm showing you here are the words of highest feature importance scaled by their frequency of occurrence. So these are the words in the lower peace countries. They're basically words of government or social control. So a lot of words like government or country or state, president, somewhere else in here is court and probably police somewhere also. What we found for the higher peace countries, we don't see these words at all very much. We still have some like government. Mostly we have words about time, very often about the future. People always think it's going to get better in the future. And we have words about daily activities, about home and work, about games and sports. So this is really interesting. When we started this project, the social scientists felt that the words they would expect to see in higher peace countries are things like maybe communication skills or conflict analysis or compassion or things like that, and that they would find very negative words in the lower peace countries. But it's surprising to us that when at least everything is going well, people aren't explicitly concerned in how they're talking to each other. They're just living their lives. So these were the words that seem to be important, that differentiate lower and higher peace countries in both their news media and in social media. This was a different version of this done by students last year, again at the Columbia Data Science Institute. And here we're using Google BERT, which deals with whole sentences, not individual words, as well as XLNet and some other machine learning tools. And again, the low peace countries are, and then the words here had been clustered into groups or topics of meaning by using k-means clustering. So we can see that most of the words have some connection with government or politics in the lower peace countries, a few other things like sports and some other things here. But in higher peace countries, the percentage of government things is much less. Here, this report slice means things like car accidents and just reports of different things going on in society. For the particular data they looked at, there was importance in terms of film reviews. So again, this is much more activities of daily living, and this is much more about what's going on in the government and political things. So now that we've trained the machine learning system on these extreme countries, for example, with logistic regression, we can now also use it to analyze countries it's never seen before from the intermediate group, which is shown here by the countries with the white backgrounds. And we can use logistic regression to give us the probability that a country is in the higher peace group. Then what we're going to do is multiply that probability by 100 to give us an index which tells us how peaceful the country is, running from 0 to 100. And what I've done here now is ordered the countries in the order of that index. And what you can see, first of all, we can't compare these numbers directly to these other peace indices because there's a little bit disagreement amongst them. But we can see that this ordering has pretty much correctly identified all of the lower peace countries and correctly identified the higher peace countries. Well, more importantly, you can see that this ordering has put the intermediate countries pretty much in between the lower and higher peace countries. So what that means, it means from the frequencies of the words on the extreme countries, the machine learning model is able to identify from their word frequencies that they should be placed in the middle of this in a different way. So this gives us greater confidence that the whole system that we're doing is working. It also gives us now a tool to analyze any kind of data, in this case, text data, from countries in order to organize things. So the results of this are that the machine learning tools can accurately classify countries as lower or higher peace from their news and social media, that there are more words of government control in lower peace countries and more words of daily activities in higher peace countries. And we've trained this machine learning models, or once they've been trained, can provide a quantitative level of peace from media data. And the broader lessons of this are that you better be sure what your NLP pre-processing is going to do and really check results. Sometimes that's not quite doing what it is. You should be careful about which words you throw away, maybe doing the standard thing of throwing away the stop or common words is not the best thing to do. There are a lot of decisions you have to make in how you handle data that's inconsistent from different data sources, how you will balance different amounts of data. And one of the possibilities we found useful here was using extreme cases to improve the training. And in general, the things I think are always important in machine learning are to really understand the mathematical assumptions that your models are using and to really check that your methods are doing what they think you're doing. And it's not enough just to be a data scientist to do what the domain knowledge people have told you to do. You have to understand what they're really trying to get at, because that will really affect what method you use and how you'll interpret the results. So if I get out of this.
Well, Larry, this was very good. I really enjoyed the lecture and I enjoyed the work. You're the true scientist, because there's so many people who more politicians and bureaucrats than scientists, but I can see that you love it and you do it for the beauty of it, trying to find the real answer. So just thank you. This is very good.
All right, thank you.
Okay, I guess I stopped the recording.